Hello there, CP Finite Math, and welcome back to lesson 6.5.2. I decided to, for the practice, do a little walkthrough if you have some extra questions. If you don't, you certainly don't have to watch this, but I thought it might be helpful for those that may need it. So, first thing, I did look up some combinations calculators. So, if you're like, I don't have a graphing calculator, I can't do this, all you got to do is under Google, if you just type in combinations calculator, I got 220 million results in 0.43 seconds. I'm just going to click the first one, and we're just going to roll with that. So it can be very helpful for us for these next particular problems. Of course, if you have a graphing calculator in general, you can use it as well. So let's just start by looking at number one here. A delivery truck has 15 boxes of bananas. Giant is going to be receiving the order. So these questions should be similar to those in your notes. How many total ways can Giant receive its order of bananas? Well, there are 15 boxes, and Giant is going to be choosing 10 of them. It doesn't matter what order, as long as they get their 10 boxes, they're happy. So 15, choose 10. I don't see those words at least or at most in this particular problem, so I don't need to worry about adding. It's just a good old 15. And then choosing 10. N is 15, R is 10. Calculate 3,003. 3,003 ways they can receive their bananas. All right. It's known that of the 15 boxes, 4 are rotten. Ew. How many ways can Giant receive? At least 9 fresh boxes. So let's think about how this breakdown is. If there's 15 total, okay, 11 are fresh because 4 are rotten. Now, at least 9 fresh boxes. At least, again, means that we have different scenarios. So scenario number 1 is that we end up with at least, so 9 fresh boxes, which means if our order is 10, we have 1 that is not fresh. Okay? Or scenario 2 is that at least 9 fresh boxes, well, we could get all 10 good. That falls within at least. And we could have no bad boxes. So that's kind of the ideal case, but we want at least 9. Okay, so for the fresh boxes, I'm getting 9, and there are 11. So there's 11 total. I'm choosing 9. That's what this 9 references. The 1 rotten box, there's 4 of those, so it's 4, choosing 1. Now remember, within each scenario, you're multiplying. Okay? And let me just also highlight, so there's 11 good boxes. That's this 11. And there's 4 bad boxes. That's this 4. This 9 goes there. And this 1 is here. So colors might be helpful. Or is when we add. So multiplying within the scenario, adding the different ones. So 10 fresh. There's 11, I'm choosing 10. 0, rotten. So times 4, choose 0. And when you have those set up, then you can just kind of go about and multiply. So I did bring up that calculator. That can be helpful. It will be more useful if you have your graphing calculator, just because we can do it a little quicker here. So 11 choose 9 times 4 choose 1. I'm just going to make sure I put that in parentheses. 11 choose 9 times 4 choose 1. And if I end parentheses, I can actually do the addition right to the 11 choose 10 and 4 choose 0. So 11 choose 10 times 4 choose 0 And that just gets me to 31. So 231 ways they can get at least 9 fresh boxes. Okay? How many ways can they receive at most 1 rotten box? So again, it's always a great idea to write out your scenarios first. So that means 1 rotten, and that means I need 9 fresh, because there's a total of 10 boxes in the order. Okay? Or, at most 1 rotten box. That means I could get 0 rotten and 10 fresh. Okay? So let's just think about how we'd set this up. So I'm choosing 1 rotten from 4. So 4, choose 1. And then the rest of my order is 11, choose 9. Or means to add. 4 choosing 0, I don't want any rotten. And 11 choosing 10, all fresh. And you can set that up. You can certainly type that into your calculator. One little trick, I did kind of throw this in there. It's really the same question as B. It's really kind of asking you the same thing. If you notice, our scenarios are the same, they're just switched. So you should end up with the same answer, because at most 1 rotten and at least 9 fresh would really be the same thing. So you should get 231. You can certainly double check me in your calculator with all that stuff. For time's sake, I will just move on to the next problem. Soccer coach selecting field players, 10 of them from their roster of 17 varsity, 13 JV. Okay, how many ways can the coach select a lineup of at most 1 JV? At most 1 JV, okay. For our lineup of 10, that means I would have 1 JV, okay, and 9 varsity. Or I could have no JV and 10 varsity. There's no other scenarios. Okay, so I'll at least get you started with the combination stuff. So of our JV, just remember there's 13 total. So there's 13, and I'm choosing 1. And means multiply. There's 17 varsity, and I'm choosing 9. Okay, so in that case I'd multiply, or I would add 0 JV, so 13 choosing none of them, and then 10 varsity, 17 choosing 10, multiplying those, adding in between. That is the setup at least, and I'll let you type it in to find the answer. How many ways can the coach select a lineup of at least 8 varsity players? At least 8 varsity. So this one we have a little bit more, but let's just think. So 8 varsity. The rest of the lineup would need to be 2 JV. Or you could have 9 varsity and 1 JV. Or I could have all 10 varsity and no JV. So just a few more. This is just a 3-case scenario. But really the same idea. There's 17 varsity. I'm choosing 8. Times 13 JV, choosing 2. Or means to add. 17 varsity, I want 9 of them. 13 JV, I want 1. And lastly, 10 varsity, 17, choose 10. And 13, choose 0. So that's the basic setup. Your calculator will find the answer for you. Hand of 5 cards dealt from a deck of 52. How many hands contain at least 4 spades? So when dealing with cards, you just have to recognize what we're considering spades. Remember, there are 13 spades in a deck of cards. So to have at least 4 spades and a fifth of 5, there are 13 spades. That means there are 39 other cards. So at least 4 spades, we have our different scenarios. Okay, we have scenario number 1, which would be 4 spades and 1 other card. Or scenario number 2, which would be all 5 spades and 0 others. How we would set those up combinations wise, so there's 13 total spades. I'm choosing 4. And I want 1 other card. There's 39 of those. I'm choosing 1. That's the first. Or I add that to, this time 13, choosing 5, times 39, choosing 1, 0, 0. And that will get me the solution. And at most, 1 jack. That means, so at most, I would have 1 jack and 4 other cards. Or 0 jacks and 5 others. So for the 1 jack and 4 other cards, that's 4 jacks total. I'm choosing 1 times 48, choosing 4. Or means to add 4, choosing 0, and 48, choosing 5. Okay, so setting them up, I at least got you through that. Again, pat yourself on your back if you're anywhere close to setting these up. I know they're tricky. I know you're doing your best. I hope you are. And continue on just solving these in your calculator, finding those solutions. But after you get them set up, hopefully you feel a little more comfortable now. So thanks for watching. If you had questions, also an email away. So great job, guys.